Good afternoon. Why don't we get started? Just a few reminders. So let's continue with what we've been talking about. We've been doing a set of calculations. What I want to move into today is looking at estimating emissions. This will play very much into Project 1, and we'll talk about Project 1 towards the end of class. So thinking about this, okay, if we're looking at a stationary source and we're trying to determine whether or not, for instance, this stationary source here can either make substantial modifications or they want to build a new facility, how do we go about assessing whether or not they can do that? What are the factors that we want to look at? So let's try and think about that together. Okay? So we've got this power plant. It's a 50-year-old coal-fired power plant. They're looking at doing significant modifications. What do we look at? What information do we need? What questions are we going to ask? Feel free to unmute yourself, okay? Exactly what pollutants are being released. So we want to know what pollutants are being released. What else do we want to know, for instance, about those pollutants?
The concentration.
Okay. And typically, concentration, most importantly, what we're typically looking at is a mass rate. So rather than the concentration, typically your permits will be written for a mass of pollutant emitted on a temporal period, over a temporal period, so over some time period. What else and so this kind of addresses the amount of pollutant. What else would we need? What else do we need to think about with these pollutants?
Their effect on the environment.
Okay, the effect on the environment. So their toxicity, both to humans and the toxicity to biota, so organisms in the environment, their effect on material, so buildings, for instance. What else?
Weather patterns.
Okay, we're going to worry about the weather, and we'll get into that later when we talk about modeling. Back kind of thinking about the pollutants, what else do we need to think about with these pollutants? We talked about primary and secondary. What do we mean by those terms when we're talking about the pollutants? Primary pollutants are emitted directly from the smokestack. So directly out of the smokestack are emitted primary pollutants. However, those primary pollutants can react in the atmosphere to produce secondary pollutants. We also need to be concerned with those secondary pollutants. So the secondary pollutants can actually be more harmful than the primary pollutants. What else do we consider? These are the exact same questions that you will ask within your groups when you're doing Project 1. So what else do we want to think about?
Kind of with that primary and secondary pollutants, would it be like bioaccumulation?
Okay, so it could be bioaccumulation. So for instance, we've put in strict regulations for mercury. In fact, one of the major reasons why the MSU power plant switched entirely from coal to natural gas was because of the mercury regulations. It was too costly to comply with very strict mercury regulations, it was actually cheaper to switch to natural gas. Mercury bioaccumulates. So we're concerned with mercury releases in the atmosphere. So that plays into another question that you need to ask in terms of addressing this question of, do you build this new facility, modify an existing one, interested in what I just said, the economics. How much is it going to cost? So how much would it have costed to maintain a coal-fired boiler, which there are 4 boilers in the MSU power plant. They had switched 3. That 4th one was the last one that could burn solid fuel. So it was actually could burn coal, but it could also burn biomass. They had to make a decision what to do with that burner. Once they made the decision to switch to natural gas, that was it. Going back isn't feasible. It's not cost effective. So when you're looking at that, okay, they had a set of regulations. They had pollutants that they needed to consider. They needed to look at the economics and use that information to make a decision about whether to maintain that last boiler as a solid fuel boiler or to switch to entirely to natural gas. They switched to natural gas. Anything else? Has anybody ever been near a paper processing plant? Maybe there's some of you in the UP. Okay, paper processing plants are notorious for malodors. Kind of smells like rotten cabbage. So another thing that you want to consider are the characteristics of the emissions. So this can include odor, color, acidity. So you're not necessarily looking at a particular pollutant per se, but you're looking at the characteristics. So we can think about this in terms of the East Lansing wastewater treatment plant, notorious for malodors. Where do we place that? Okay, so somebody mentioned that near Detroit, there is a factory and it kind of smells like fermenting oats. Not sure what factory it is, but again, that's another issue. So how do we deal with that? And so if we're looking at making process modifications, or if we're looking at expanding that plant, what impact do those odors have on the communities surrounding that plant? We also need to consider, is that source what is referred to as a major source or an area source? Under the Clean Air Act amendments of 1990, and that is the last time amendments to the Clean Air Act have been promulgated, there are 187 air toxins that have been named and are regulated. So a major source is one that emits 10 tons per year or greater of any HAP or hazardous air pollutant, or 25 tons per year of a mixture of HAPs. That's the definition. An area source emits less than that. From a regulatory perspective, that's what we mean by a major source and what we mean by an area source. So we need to move forward in looking at this. So think when you're looking at project 1, this is exactly the process you're going to have to follow in preparing your report and recommendations for project one. So the next thing we need to think about is conducting an emission inventory. So we can do this in essentially two approaches. One, we can think about and list the pollutants from all sources entering the air in a given time period for in a specific area. So let's think about this. If we were to think of carbon monoxide. So we're focusing our inventory and ultimately our recommendations, and really you'll write it in terms of recommendations. If you are working for EGLE or another one of the state agencies or the federal government that has primacy over the Clean Air Act regulations, you'd be following this approach. So you'd be looking at this in terms of permitting. So if we're looking at carbon monoxide, let's just think of the East Lansing MSU area. What are the sources of carbon monoxide in that area? So we're going to focus, we've defined an area. We're going to say that this area is MSU and East Lansing. Okay. And the pollutant we're looking at right now is carbon monoxide. So we need to, at this point, determine or list what are the sources. What are all the sources that you can think of in MSU and East Lansing of carbon monoxide?
Cars.
Cars, good. What else? Train, cows, agriculture, smaller amount, but potential. Main source is carbon dioxide, but there would be some carbon monoxide.
Industries.
Okay, so any industry in the area.
Power plants.
Power plant. So heating and cooling. So furnaces. Cooling really gets tied back. Most of your cooling is with air conditioning. It's electric, so it's really tied back to the electricity use from the power plants. But the furnaces are in the home, so that's a direct emission. Anything else? Snowed on the weekend. Any sources of carbon monoxide? How about snow blowers? So we want to list the sources. So here we're focusing on the pollutant and we're thinking of the sources. Now, let's just focus on one source. Okay, so let's focus on home furnaces. The next thing we want to do is to determine the type of air pollutant emissions from those sources. So we've listed a number of sources. We're going to focus on one source. We'll focus on home furnaces. And then we need to think about what are the pollutants. So for example, a gas-fired boiler furnace emits carbon monoxide. What else? What pollutants are emitted from a furnace other than carbon monoxide?
Nitrogen dioxide.
Okay. It's a combustion source. What are the two chemicals produced from perfect combustion? Good. CO2 and water vapor. We don't typically think of water vapor as a pollutant, but we'll list it in terms of emissions. Anything else?
Sulfide.
Exactly. So typically in the form of sulfur dioxide. You can also produce NO and various volatile organic chemicals. What we want to do today is we'll look at how do we even begin to start to assess this. Okay, so once we list the type of pollutants, now we need to determine the amounts of pollutants, and then we need to determine the health and environmental effects of each of these pollutants. Now, in terms of where do we get this information from? Now, if we look at furnaces, we need to think about how many furnaces are there? How big are they? How much fuel are they burning? Ultimately, what we're looking at is trying to obtain enough data that we can quantify emissions. So where do we get the data? One, potentially, are source-specific tests. Someone has monitored the emissions from these sources. In some areas, in order for a car to be roadworthy, it actually has to go through an emission test on an annual basis. So, for instance, if you were living in an area that required such testing, then you could obtain that data potentially from, for instance, New Jersey, where I grew up. It's a motor vehicle department that ran the inspections, would have had all this data from on an annual basis from all of the cars that had to be inspected. And then that data could be fed into your model in order to quantify emissions. That's not often available. And then we're forced to examine the literature, which is what you will do for Project 1, to try and determine valid emission factors. So for each pollutant of concern, then you need to determine an emission factor for that pollutant, and then can use that information to determine total emissions. So let's think about this in terms of context of a situation. So you're asked to estimate the amount of carbon monoxide from oil burning furnaces emitted per day during the winter in a small city of 50,000. How do we go about doing that? The first thing we want to do, or we will need to do in order to assess that.
Research how much a furnace emits, an average furnace.
We need to do that. Okay, before we even do that, we need to define our system boundary. So if we're looking at the small city, is it how far out? Okay, do we look at? If you think about MSU and East Lansing, and we're looking at answering this question, do we just include MSU and East Lansing? Do we start looking at Lansing? Do we look at Okemos? Do we look at Holt? What is our system boundary that we need to think about? Okay. Now we need, once we do that, then I've essentially told you this. The next thing we need to know is what's our pollutant of concern. So we need to think about that. The next thing we need to do is exactly what was just stated. We need to figure out how much does a furnace emit. So we need an emission factor for the particular source. And we need to know, in this case, either the amount of fuel burned, the number of furnaces, but we're going to, your emission factors will be dependent on some unit. In the case of oil furnaces, it's in the amount of oil that's burned. So in this case, we need to know the amount of oil. So we've determined the system boundary. We're going to say that it's the city limits. We've said that we're looking at carbon monoxide. Okay. The emission factors, there is a document produced by EPA that is referred to typically as AP42. To tell you the truth, I'm not even sure what the full name of it is, but basically it is a document that contains emission factors for a whole variety of sources. So table 1.3-1 includes data for a number 6 oil-fired normal firing boiler. That's what we will look at. And that states that 600 grams of carbon monoxide are produced for every 1,000 liters of oil that is burned. And it is given a rating of A. So you'll find when you look at these, you'll see that the emission factors are actually given a rating from A through F, and that provides you with information about the reliability. So there's a significant amount of data available for these number 6 oil-fired normal firing boilers. The data is consistent, so it's given a rating of A. Now, how do we figure out how much oil is burned? Where do we go for this data? What if we went to the dealers? Somebody is selling and delivering oil. These homes that are burning oil, they would have records. They would know how much oil they're selling. So from there, we could obtain this information. So we go to them and we find out that on average, they are selling 40,000 liters per day to this population. In which case now we can determine the amount of carbon monoxide emitted by these homes on a daily basis. So if we have 600 grams of carbon monoxide, 1,000 liters, we have 40,000 liters per day that we're selling, and we'll multiply this by 1/1,000 grams per kilogram in order to convert to kilograms. And we calculate 24 kilograms per day as the emission rate for carbon monoxide from the homes in this city.
Yeah, where did you get the 40,000 liters per day again?
I went to the dealer. So there were dealers that are selling oil, and I went to the dealer and I asked the dealer and the dealer was cooperative. Dealers were cooperative, and they could provide how much oil they were selling really over a season. So from that I could get 40,000 liters. Let's think about this in terms of carbon monoxide emissions. So we're looking at now carbon monoxide emissions from cars in the Lansing area. What do I do? How do I proceed? And the first thing you always want to do is determine your system boundary. So when we talk about Lansing area, what's our boundary? Lansing, Diamondale, Okemos, Haslett, Holt, East Lansing, MSU. We need to define our system boundary. What else do we need to know? Get pollutant. So we need to know what pollutant we're looking at, and we've said that it's carbon monoxide. What else?
Maybe how many homes are in the Lansing area?
Okay. So we're looking at cars.
But then you could like deduce like maybe 1 car per home.
Okay. So we could do that. We could look at the number of homes and from that deduce how many cars. How else could we get the number of cars?
Number of people employed in the Lansing area.
We could look at the number of people employed and then make some assumption. We could look at traffic studies. We could go to the Secretary of State's office because the Secretary of State knows exactly what cars are registered in this area. So we could use these again to determine the number of cars. What else do we need to know? Is this enough to tell us? We need to know emission factors. So we need to know something in order to determine the emission factors for a car. What do we need to know? If 100% of the cars were electric, what would be the emission factor from the direct emission from those cars? 100% were electric cars. What's the emission factor?
If they were electric, they wouldn't have a gas mileage, right? And you wouldn't have like miles per gallon. So is that what you're looking at?
That's exactly, it would be zero, right?
Right.
Maybe carbon monoxide from the power plant, but not from the tailpipe because there's no tailpipe, right? So you need to know something about the car. We need to know the make, the year. We need to know the miles driven. We can make some assumptions, but we need to document those assumptions. We can look at, for instance, the amount of gas that is sold in the area. And then from that, and knowing something about the make, the year, we can then estimate the carbon monoxide produced. Type of fuel would matter, whether it's diesel or gasoline would definitely matter. Diesel, you'll see more particulates, less carbon monoxide. So I've mentioned these AP42 emission factors. I'm not going to go into a lot of detail. I'm not going to read you this. You can do that later. But as I mentioned, they're expressed in terms of the mass of pollutant divided by some activity. So for instance, kilograms of sulfur emitted per megagrams of coal burned. Or in the case of natural gas, it will be in terms of a volume. You can obtain AP42 at this website. And AP42, you'll need it for the homework. And it may very well be useful depending on the problem you pick for project 1. So we use these in mainly the decision making we need to do in terms of determining area-wide inventories. So we can look at dispersion modeling. We can look at it for control strategy development and for screening sources for compliance. Typically, we're not going to use this for permitting. It provides us some background information, though, that assists with some of the decision-making process in developing. And as I mentioned, these have ratings. So it's at A through F. It's actually A through E. A is excellent. So as I mentioned, you have a plethora of data. That data is consistent. So the emission factor is given an A rating versus E, where there is a paucity, there's very little data, or the data is very inconsistent. So you can rely much more heavily on data with an A rating. The other thing we look at are the emission factors, but we also often need to look at reduction efficiencies. So now we're getting into looking at the permitting. So E is our emission, A is the activity rate, could be miles driven, number of or oil burned, and then we have an emission factor that we'd get from typically from AP42, and then we have a reduction efficiency. So we do one more example, and we're looking at estimating the emissions of a large NOx boiler at a 500 megawatt power plant burning natural gas. We don't have any specific information on the make or model of the boiler. So we will use the general data from AP42. So starting here, we have a 500 megawatt. That is defined as the power. So it's 500 megawatts for each hour that it operates at 100% capacity. Typically, your power plants don't operate at 100% capacity, but we will calculate the emissions, assuming operating 24/7 at 100% capacity. So if we have 500 megawatts, I'm going to multiply by 24 hours per day. That is 12,000 megawatt hours per day. The plant is burning natural gas, and that's a reasonable assumption for a low NOx boiler. And you're actually told that. So for every 1 kilowatt hour of power that we're producing, electricity that we're producing, we're going to burn 0.01 mega cubic feet, and a mega cubic feet is 1,000 feet cubed. This is the terminology that's used, and cubic feet is 10 to the 6. So let's do a conversion here. So we have 0.01011 mega cubic feet per kilowatt hour. And you'll see why I'm doing this conversion in a second. So all I've done is I've done a conversion here to convert to use million cubic feet per megawatt hour. And the reason I'm going to do that is because when I go to AP42, and we'll go to section 1.4, the emission factor is 140 pounds of NOx per million. It's actually what given is million standard cubic feet. So the standard cubic feet is for standard conditions, which is defined as 60 degrees Fahrenheit and 14.7 psi. So now that we have that, if we now take, we've got 0.01011 million cubic feet per megawatt hour. I'm going to multiply that by 12,000 megawatt hour per day times the 140 pounds per million cubic feet. Million cubic feet cancels, megawatt hours canceled, and what we have is the concentration in, or sorry, the emission rate as 16,990 pounds per day. So what we've calculated now is the emission of NOx. So this is just information about a low NOx boiler and typically how much natural gas is burned for every kilowatt hour. And then our emission factor is from AP42. In terms of project, and we have a few minutes, but in terms of project one, what you will do is you will write a report, and what you're doing will do is you will provide a recommendation, and your recommendation will be to either Meridian Township Environmental Commission or the MSU Board of Trustees regarding the creation of an ordinance that would limit or eliminate emissions. So you will address the types and quantities of pollutants emitted, the health and environmental effects of these pollutants. You will pick one source. So I've given you 6 different choices. You'll pick in your group which one. If you don't like any of those and you want to investigate a different source, then what you'll need to do is let me know, and we'll discuss what that source is and who the audience would be for your report. When you're developing your recommendation, you're going to go through the process that what we essentially did, but you'll look at short-term, long-term impacts of the pollutants. You'll look at the toxicity. So we'll move on Wednesday into a unit looking at health effects. This addresses this whole issue of what is the toxicity, what is the pollutant. What is the population that is likely to be exposed? How vulnerable are they? Are they very young? Are they very old? How densely populated is this area? Are the sources seasonal? Are there alternatives? Are there effects, for instance, greenhouse gas emissions or economic impacts of your ordinance and how strict that ordinance is? Can MSU, Meridian Township, or the other regulatory body actually implement the ordinance? What would they have to do? So this will be prepared with a cover letter. Your cover page will include title, names of all the team members, and your team number. Your introduction includes an identification of the problem, and then your discussion gets into this whole issue of what are the pollutants, how much is emitted, what is the impact of these pollutants, and then you will make a recommendation. This goes beyond just a typical report that you would write. That recommendation is important. So you'll do this analysis based on your analysis. For instance, should coal tar sealants be banned? What is the impact of that? And this is due on February 22nd, and you'll submit it on LONCAPA. So it just gives you, all of this is posted now on LONCAPA in the project folder, project one. What I've tried to do is build this around the units of what we've been looking at, the type of calculations we've done, and then the health effects that we will look at over the next week or so. Any questions?